So today, we're going to dive into a really groundbreaking AI framework. It's one that's designed to completely change how we understand and predict outcomes for one of the toughest brain cancers out there. This is all about moving from a single static snapshot to a dynamic, evolving picture of a patient's entire journey. Okay, so here's how we're going to break this down. First, we'll get a handle on the glioma challenge itself, why it's so tough. Then we'll look at how AI has been trying to help so far. After that, we'll get into the exciting stuff, a powerful new tool, the core innovation called Glosserve QNET, and of course, its incredible results. We'll wrap up by talking about what this all means for the future. All right, to really get why this breakthrough is such a big deal, we first have to understand the problem it's trying to solve. So let's start with the glioma challenge. Yeah, this right here, this quote pulled straight from the research, it isn't just a statistic. It's the urgent reality that drives researchers to find better tools. It's about giving doctors and patients a much-needed edge against a relentless disease. You see, gliomas, which come from the brain supportive cells, basically fall into two big buckets. And this difference you see here, it's not just a small detail. It's the difference between a prognosis measured in years, maybe even a decade or more, and one measured in just months. That's why getting an accurate classification early on is absolutely critical. So we know the problem is huge. How have we been using technology to fight it? Well, let's look at AI's traditional and kind of static approach to all this. For a long time now, AI has been a huge help, no question. You've got machine learning models that can crunch all the numbers from scans, and you have deep learning models that can actually look at the raw images and automatically outline the tumor. Kind of like a radiologist, but way, way faster. But, and this is the big but, there's a fundamental problem here. These older methods work like a simple camera. They take one input, say an MRI scan, and give you one output, like a tumor grade. It's a snapshot in time. What it can't do is capture how the disease changes and evolves. And that limitation? Well, that's exactly where the story gets interesting. It basically forced a whole new way of thinking, leading to a much more dynamic and responsive tool. So, enter reinforcement learning, or RL. Instead of just taking a single snapshot, RL is all about learning from experience. Think of it like a video game. The AI agent makes a move, sees what happens, and gets points, or a reward for a good move, and a penalty for a bad one. It learns and gets smarter over time, making it perfect for modeling something as complex and ever-changing as a patient's health. Now, what's so cool about this research is that they spotted this huge, empty space. They realized that predicting survival isn't a one-and-done thing. It's a process that unfolds over time. So they thought, why not use a dynamic tool like RL for a dynamic problem like this? It was a brilliant insight. And that brings us right to the star of the show, Glosserve QNET. This is the new framework they built to fill that gap. Okay, so what is Glosserve QNET? Think of it as this super smart, custom-built system. It uses a very specific type of reinforcement learning that's designed to pay close attention to the most important clinical data. It does two crucial things. First, it nails the tumor classification, and second, it predicts patient survival. It was built from the ground up to tackle big problems like not having enough data and the fact that most AI is a black box you can't see inside of. Take a look at this. This diagram basically lays out the whole pipeline. You start on the left with the raw MRI scans. The system then works its magic, pulling out these key features. Quantifying things like the tumor's shape and texture, it's literally turning a complex medical image into a sheet of data that the AI can understand. That data then gets fed into the heart of the system, the RL model, which then delivers the final outputs on the right, the classification and the survival prediction. So the theory sounds great, the framework looks slick, but does it actually work? Let's get to the results, because this is where it gets really good. Get this, 99.27%. When they used two specific types of MRI scans that are great at showing tumor details, the model achieved nearly perfect accuracy in telling the difference between low-grade and high-grade gliomas. That's just incredible. Okay, but here's what really blew my mind. You know, in the real world, you don't always have tons and tons of perfect data to work with, right? That's a huge problem for AI. But this model? Even with limited data, it hit a perfect 100% accuracy. That shows it's not just accurate, it's incredibly robust, which is exactly what you need in a hospital. Now, this table is super interesting because it's not just about a high score, it's about context. You can see how this new method stacks up against what came before. It just blows most of the older models out of the water. And while one other method also hit 100%, this new framework does it with amazing stability and efficiency. It really is a step up. So, what does all this mean? Let's wrap up by looking at the bigger picture, because this could really signal a new era for how we approach prognosis. When you boil it all down, the big takeaway isn't just about one fancy new model. It's proof that this new way of thinking works. Using reinforcement learning can get us beyond those static predictions. It opens the door to truly personalized prognostics that can adapt over time. And because it was designed to be explainable, doctors can actually understand why the AI is making a recommendation, which is an absolute game changer for building trust. And of course, a huge shout out and acknowledgement to the researcher, her guide, and their university for this really pioneering work. So this all leaves us with a really powerful and, honestly, optimistic question, doesn't it? We might be right on the edge of a time when AI isn't just a fortune teller giving a one-time prediction, but a dynamic partner that adapts and learns right alongside a patient's journey. Just think about what that future could look like.